Hello everyone, welcome to my project presentation. Today I will be explaining my project title Analysis on IMDb movie reviews using a deep learning. The main objective of this work is to compare how different neural network architectures perform when classifying text. Specifically, I experimented with a simple dense neural network, a convolutional neural network, a long short-term memory network. These three models were trained on the same dataset using the same pre-processing steps and evaluated using accuracy, confusion matrices, ROC curves, and AUC scores. The idea is not just to build a model, but to understand why some models perform better than others when dealing with the sequential text data. Throughout this presentation, I will explain the dataset, the pre-processing steps, the model architectures, the evolutionary matrices, and finally compare the results to determine which model is the most effective for a sentiment classification. For this project, I used IMDb movie review dataset provided directly by Keras. IMDb stands for Internet Movie Database, one of the world's largest platforms for movie ratings, reviews, and metadata. The dataset contains 50,000 movie reviews in total, 25,000 for trainings, 25,000 for testing. Each review is labeled as 0 negative, 1 positive. The reviews are pre-processed into sequence of integers. Only the top 10,000 most frequent words are kept. 0 every review is padded to 200 words. 0 negative, 1 positive. The reviews are pre-processed into sequences of integers. Only the top 10,000 most frequent words are kept. 0 everywhere reviews in padded to 200 words. This standardization ensures that each model receives input of exactly the same size, making a training stable and efficient.
Now let me go through the main components of the code used in this project. First is importing libraries. We start by importing the essential libraries like TensorFlow or Keras for building neural networks, NumPy for matrix operation, scikit-learn for evaluation matrix, matplotlib and Seaborn for visualization. These libraries together form the core toolkit for modern deep learning workflows. Next is loading and pre-processing the data. We load the IMDb dataset. This ensures we only consider the top 10,000 words from all the reviews. Then we apply padding. Padding is extremely important because neural networks cannot process variable length inputs. By padding all sequences to 200 words, every review becomes a uniform input vector. Creating a reusable evaluation function. One of the most important parts of the coding is evaluation function. It performs, generates prediction, converts the probability to binary 0 or 1 output, and computes the accuracy, calculates the false positive and false negative, plots the confusion matrix and plots the ROC curve, and calculate the AUC score. Using one function to evaluate all three models ensures a fair comparison. Dense model architecture. Dense model uses an embedding layer, global average pooling layer, a single dense output layer. This model is simple and acts as a baseline. However, it cannot understand the word order. It only sees an average representation. So next is the CNN model architecture. CNN model includes embedding, 1D convolution, max pooling, and dense output. CNN excel at identifying the local patterns like short phrases, n-grams, and sentiment high section. This model performs better output because it captures the small pattern within the text. Next is the LSTM model architecture. LSTM model uses embedding, LSTM layer, dense output. LSTM maintain a hidden state which acts as a memory. They can understand long sentence, context, previous words, relationship across the sequences. This is why LSTMs are widely used for NLP tasks such as translation, speech recognition, and sentimental analysis. Next is the combined ROC curve. At the end, we will plot all the ROC curve in a single graph. This helps us visually understand which model distinguishes the classes more confidently.
After training, here are the results. For dense model, the accuracy is 70% and area under curve is 0.79. This model performs decently for a basic architecture but struggles with the complex sentences. And for CNN model, the accuracy is 78% and area under curve is 0.87. The CNN performs better because it captures local patterns such as not good, very bad, absolutely wonderful. These short phrases play a major role in the sentiment. LSTM model, the accuracy is 83% and the area under curve is 0.91. This is best performing model because it understands the flow of language. Even if a sentence is long, the LSTM can track sentiment changes. For example, at first I thought movie was slow, but eventually it became one of the best films I have seen. A simple model might classify this as negative due to slow, but LSTM identifies the overall sentiment as positive. Importance of AUC score. The AUC stands for area under the ROC curve and it is one of the most important evaluation metrics in the binary classification tasks like sentiment analysis. Unlike accuracy, which one tells us about many predictions were correct, AUC tells us how well the model separates the two classes across all possible classification thresholds. AUC ranges from 0 to 1. AUC equal to 1.0, which is a perfect classifier. AUC which is equal to 0.5 is a completely random predictions. AUC less than 0.5, it is worse than random. AUC is extremely useful because it works well even if the data is imbalanced. AUC is extremely useful because it works well even if the dataset is imbalanced. It measures the quality of predictions, not just quantity. It shows how confident the model is in distinguishing positive and negative reviews. In our project, the AUC scores clearly shows the strength of each model. For dense model, it is 0.79, performs decently but lacks deep understanding of concept. For CNN model, it is 0.87, better at detecting important phrases. For LSTM model, it is 0.91, highest separation power, meaning most predictions are made confidently. In the ROC graph, the LSTM curve rises very sharply towards the top left corner. This steep rises indicates that the LSTM is accurately identifying positive and negative reviews over almost all threshold values.
Next, let's look at the confusion matrix result. A confusion matrix allows us to understand the types of errors the model makes. True positive, positive reviews correctly predicted as positive. True negative, negative reviews correctly predicted as negative. False positive, negative review incorrectly predicted as positive. False negative, positive review incorrectly predicted as negative. Good models have high true positive and true negative and low false positive and false negative. When comparing the confusion matrices, the dense model has higher numbers of incorrect predictions, especially false positives. The CNN model reduces these mistakes significantly because it recognizes strong local patterns. The LSTM model has the lowest false positives and false negatives overall. This is important because fewer false negatives mean the model rarely misses positive sentiments. Fewer false positive mean it rarely misclassifies negative reviews as positive. Overall, the LSTM shows more stable and reliable prediction behavior which supports the AUC and accuracy results. To conclude this project, we experimented with 3 different neural network architectures to classify sentiment in IMDb movie reviews. Across every evaluation metric, accuracy, AUC score, ROC curve, and confusion matrix, the LSTM stands out as the best model for sentiment analysis. This project clearly demonstrates that sequence-based models are far more effective for natural language understanding compared to simpler architectures.
So at first we will start by importing the libraries such as NumPy, Matplotlib, sklearn, TensorFlow and the Seaborn. Next is we will load the IMDb dataset and then they truncate each review to length 200. Next is the function to calculate the ROC matrix and the confusion matrix, and then we will plot the confusion matrix. First is the dense model. In the dense model, embedding of all the vectors and the averaging of the vectors and the sigmoid of the output probability. Next is the CNN architecture model. In the CNN architecture model, convolution only it is to learn the local patterns, and then max pooling it is for the length, and then sigmoid it is for the classification, and the LSTM model it learns the sequence information word order, and then combined ROC curve. Here this will plot the combined ROC curve. First is the output of the dense model. Accuracy is 0.7314 and AUC is 0.8109, and the confusion matrix, it will be like this. And then next is the CNN model. Accuracy is 0.7816 and AUC is 0.8726, and the confusion matrix, it will be looking like this. And then next is the LSTM model. Accuracy equals to 0.8347 and AUC is 0.9142, and the confusion matrix, it will be like this. And this is the combined ROC curve comparison of the dense versus CNN and the LSTM. This is the output for the ROC curve.